Hello and welcome to Gaseous Exchange altitude preparation screencast. So the key focus of the screencast is to prepare you for the lesson we're going to do on the impacts of altitude on the respiratory system. So before we do that, it's really important that we have an understanding of gaseous exchange, because that is the key part within our respiratory system that will be affected by being at altitude. So just as a quick bit on here, so if you want to just check this. So altitude then, basically, in terms of the specification, they are saying that any time that you are 2,400 meters above sea level, you are considered at altitude. I mean, really, if people are going to do altitude training, they probably go somewhere like 5,000 meters. And the impact of training at altitude is there's a reduced partial pressure of oxygen in the atmospheric air. So that's what happens. Now, I'm not really going to talk too much about altitude again. I was just giving you that as a kind of little reference point, because what we really need to have a look at now is kind of the process of how we kind of diffuse oxygen. So if you think now, if you're at altitude, you've got a reduced partial pressure of oxygen in the air. What that does is it really impacts negatively your ability to diffuse oxygen from, if you think you're breathing in here, from the alveoli, okay, when it comes into here, into the blood, from the blood then into the muscles. It really diminishes this process. It makes it more difficult to do. So if you think of that now, what we have to do just to make sure that we're back on kind of reminding ourselves what we did in year one in terms of gaseous exchange, we need to just make sure that we remember. We won't talk about altitude now, we're just going to talk about general gaseous exchange, but with an eye knowing that where we're going to move to in the next week or so. So let's have a look. When we're trying to answer a question on gaseous exchange, remember, we have to talk about, we have to think about a kind of framework. So the framework we use for this is going to be GASP DD. So you have a gasp of air, okay, and then you've got your DD at the end. So when you think of that, to exchange gases, you start off by having a gasp of air, and then you put the DD on the end. So if I just ask you now to kind of think, right, well, what we're constantly looking at is how we get, because this is a preparation for altitude, we're going to focus just on oxygen today, how we get oxygen from the alveoli to the blood. Once it's in there, how do we get it from the blood to the muscles? Okay, and that's the process we're going to be looking at and follow it. So when you're answering this question, these are the things you would start with. The first three framework triggers are thinking questions, are things to probe your memory. So if you start off, when you get a question, it's going to ask you about a gas. It could ask you about both, but usually it will ask you about one. Okay, so is it oxygen or is it carbon dioxide? Second thinking trigger question is, what area is the question asking you about, the diffusion of or between? So you're looking here, is it somewhere between the alveoli and blood, which I'll put into here, or is it between the blood and the muscles, which is here, which will be your internal gaseous exchange? On top of that, whenever talking about gaseous exchange, you have this process of a special rule, and the special rule is just the diffusion rule, which proposes that gases move from an area of high partial pressure to an area of low partial pressure. Now, once you get into a question, these are the things that you would have to think about to start with. The gas part of it is a thinking probe. From there, you're then into partial pressure stuff. So the first thing that's going to get you marks, you have to state where the gas in question has a high partial pressure and where it has a low partial pressure. Following on from that, when you know that, where the high and low is, this is called, the difference between high partial pressure of the gas and a low partial pressure of the gas is called the diffusion gradient. Okay, and if you have a diffusion gradient, a difference between high and low, obviously, that then leads to diffusion, where the gas will diffuse from site 1 to site 2. Now, at the moment, that is just a generic framework. You've got no context at the moment to apply it to. So what we'll have a look at now then, obviously our focus is eventually towards altitude. So, the only thing I'm going to ask you to look at now, at rest, we're going to look at oxygen diffusion. So let's see how we go with this then. So if I go on to here, so the question will be something like this in the exam. Explain oxygen diffusion between alveoli and blood. Okay, so if I look to that now, we get our framework over here. So straight away we look, I think, right, gas. So which gas is being asked for? So we've got oxygen, okay. Area between, so it's alveoli and blood. Special rules, gases move from an area of high partial pressure to low partial pressure. That is where we have to start understanding gaseous exchange, because at this point we've got alveoli here I've labelled, so you're breathing in. And I just think now, but if you imagine you kind of take a gasp of air, as we use for our acronym, when you do that, you have lots of oxygen coming down into your lungs and then into your alveoli. So you should be able to understand that kind of the first thing we have to do is to say where there is a high partial pressure of oxygen. Okay, so we should realize that kind of there is a high partial pressure of oxygen in the alveoli. Now, once we know that, we know that it will contrast in our site too. So now we've got to go to the blood. So now we need to consider what the partial pressure of oxygen will be in the blood. So if it's high in the alveoli, we know it's going to be low in the blood. And if you want to understand that, that's because it's deoxygenated blood coming back up here, okay, after your body has used it, you've ran, you've done some kind of exercise, and it comes back up here, blue, deoxygenated, and therefore there is a low partial pressure of oxygen in the blood, which would be here. There's a high partial pressure of oxygen in the alveoli, which would be here, which means we have an oxygen diffusion gradient. So the oxygen diffusion gradient, the difference between a high partial pressure of oxygen and low partial pressure of oxygen between the alveoli and blood. So, because we've got that diffusion gradient, that means that oxygen diffuses from here into the blood, okay, and then we can start moving it around here. So, because it's gone into the blood now, that gives us our oxygen, and that is how we would answer that question. Now, I think it's really important now, as a trigger point, you kind of think, right, okay, so now we've done that, oxygen diffuses into the blood. So when we start to talk about gaseous exchange on the next question, which will be this, explain oxygen diffusion between blood and muscles, we now know our start point is that there's a high partial pressure of oxygen in the blood. So now we know it's in that blood, it's associated with hemoglobin, so oxygen and hemoglobin, oxyhemoglobin, so there's a high partial pressure of oxygen in the blood. We now need to follow that same chain through. So I'll put the framework here so you can have a look over that if you need it, and then what I'm going to do is just ask you to see if you feel that you could kind of answer this. I'm going to leave some gaps, and you need to make sure that this is filled in preparation for the lesson. So I'll leave it like this. So if I started you off now, we've got to do our same thing. We've got to talk about where the partial pressure is high and where it's low. So I've already told you the first bit. There's a high partial pressure of oxygen in the blood. That's our kind of P start point. Then I need you to try and think, right, so what's the partial pressure of oxygen in the muscles? Then I need you to tell me where the oxygen diffusion gradient is between. Finally, I need you to tell me where oxygen diffuses as a result of this diffusion gradient being created. Okay, so if I could just get you now to feel confident knowing how oxygen goes from alveoli to blood, from the blood to the muscles, using this framework, then we will be in a good position to see what happens to oxygen diffusion as a result of being at altitude. Okay, thank you very much.